Hi, welcome to Math Minute. My name is Adam, and today we're going to be talking about indeterminate forms and L'Hopital's rule. So let's first start talking about indeterminate forms. There's a bunch of different ones, but there's really only a few we want to focus on today that will actually be helpful with the calculus and the limits and what we're actually doing. So these right here are the ones that we're going to be looking at. Plus or minus infinity over plus or minus infinity, or 0 over 0. So where these come from is if you're trying to evaluate a limit, and you actually find out that it's a form that you can't find or you can't evaluate, such as one of these, there's things we can do that will help us actually find the value of the limit. So here, for example, the limit as x approaches 1 of ln x over x minus 1. Well, if we actually evaluate this, or try to, we get ln of 1, which is 0, over 1 minus 1, which is also 0. So we have an indeterminate form, one that we need that is going to be helpful. So similarly, if we have the limit as x approaches infinity of e to the x over x squared, once again we're going to get an indeterminate form. In this case, it's infinity over infinity. So we see these limits a lot, but what do? Do we just stop? Well, there's actually something that's very helpful, and it's called L'Hopital's rule, and we can use that. So what that says is, if the limit as x approaches a of f of x over g of x, or a fraction, equals one of the indeterminate forms that I just discussed, plus or minus infinity over plus or minus infinity, or 0 over 0. Then what we can do is we can take the derivative of the top and the derivative of the bottom, and it will equal the same limit. So if you see that, we just differentiate the top part and differentiate the bottom part and carry on as normal. So I'll do that. I'll show these examples of these two that actually gave us indeterminate forms, and we'll see how it works. So in this case, we already know that this equals 0 over 0. So what we're going to do is we're going to say, by L'Hopital's rule, we can say that this actually equals the limit as x approaches 1 over 1 over x over the derivative of x minus 1 is just 1. So what this is we have the limit as x approaches 1 of 1 over x, which now, by the direct substitution property, we can just plug that 1 in, and we get 1 over 1. So, although this looked like we had no idea, no way to solve it, it was actually 1. We were given an indeterminate form, we applied L'Hopital's rule, we differentiated the top and the bottom, and we actually evaluated the limit. Let's do the same thing down here. So once again, we have infinity over infinity. Therefore, by L'Hopital's rule, we can differentiate the top and the bottom. Well, this one almost looks like we have no hope after we differentiate it once. We take the derivative of the top and we get e to the x again. Well, that's a problem. Now we're starting to run into problems, it looks like. Well, underneath we have 2x. So if we plug this in again, we're going to get infinity over infinity. Once again, another indeterminate form. So there's nothing that says we can't apply this again, because what this says is that this is just a new limit which we can apply L'Hopital's rule. So let's do it again. So once again, by L'Hopital's rule, we can take the derivative of the derivative. So we have the limit as x approaches infinity of e to the x over 2. Now we can plug that in, so we're going to get infinity. So at first it almost looked like when we had infinity over infinity, some of us might have been thinking, okay, it's going to be 1, they're approaching infinity similarly. But what actually goes on is that this top part is approaching infinity faster than this part. So with this, we've shown that L'Hopital's rule can be very helpful when we're trying to evaluate limits. Some things might throw us off, but now with calculus and L'Hopital's rule, we can pretty much tackle about any limit. So hopefully it's been helpful, and we'll see you next time.